Hi everyone, we're Group 22. My teammates are Puyu Li, Zhenyu Liu, and me, Xuan Wang. Our topic is research and improvement of RSA algorithm. Our presentation will divide into 5 parts. Introduction, RSA algorithm, the improvement of RSA algorithm efficiency, the security of RSA algorithm, and conclusion. The first part is introduction. RSA algorithm is widely used in the field of information security with its good confidentiality. However, the computation efficiency of this algorithm is low. So this research project will first introduce the improvement of RSA efficiency and then introduce the security enhancement of RSA. Before we introduce these 2 parts, let's review the RSA algorithm. RSA is named after the initial of 3 designers, Rivest, Schimmer, and Edelman. The algorithm has 3 main steps, which including generating the key, encrypting the message, and decrypting the message. In the part of generating the key, first choose 2 large prime numbers PQ, and then calculate the n equals to PQ, and phi n equals to P minus 1, Q minus 1, and the D equals to inverse of E mod phi n, and then encrypting the message using the public key. So the cipher task equals to message power E mod n, and the last step is decrypting the message. The plain text equals to cipher text power D mod n. And here is the traditional RSA complexity. The time complexity for generating the key including 2 parts, finding the greatest common divisor and the computation of modular inverse. The time complexity of finding greatest common divisor is O phi n divide 2, and this time complexity is O phi n because it uses exhaustive method. So the time complexity for generating the key equals to phi n. The modular power operation uses recursion method, so its time complexity is On, and the time complexity of encryption is OE, and the decryption is OD. In this part, we will introduce the improvement of RSA algorithm efficiency. First, we will introduce 2 kinds of algorithm. The first one is multiple decomposition algorithm for modular n. This method is to decompose modular n into multiple prime numbers. This method is defined as shown. First, randomly select key prime numbers P1 to Pk, and then calculate n equals to P1 to Pk. Phi n equals to P1 minus 1 multiple to Pk minus 1. After that, randomly choose integer e satisfy GCD phi n equals to 1. And then compute d such that ed equals to 1 mod phi n. Then declose ne as encryption key and decryption key as nd. P1 to Pk and phi n are secrets. And last, we will get encryption algorithm and decryption algorithm. Multiple decomposition algorithm for modular n can improve the key generation phase, which improves the key generation speed and reduce the algorithm execution time. The second algorithm is load balancing algorithm. This algorithm is used to improve the large integer power multiplication. This idea is as shown that the plain text m can be decomposed into multiple small integers, say equals to m1 multiple to mk. Then the encryption algorithm becomes say equals to m1 multiple to mk power e mod n. And it can be further deformed to say equals to m1 power e to mk power e mod n. It can be seen from the equation that m1 to mk are not connected to each other, but exist independently. So each part can be assigned to computational process. But here is the problem. The size of each integer may be different after the large integer is decomposed. So the load balancing algorithm is to make the task allocation of each process more reasonably, so it can be increase the speed of RSA. The two most important phases of RSA are key generation and the process of encryption and decryption. And here, this method, RSA integrated decomposed algorithm, combine the above method. In the phase of key generation, it is the multiple decomposition algorithm of modular N, as shown in this PowerPoint. And this improves the speed of key generation. And in this part, it is in the phase of encryption and decryption phase. It is load balancing algorithm to decompose the plaintext and distribute the plaintext as evenly as possible during the computation to increase the speed and reduce the computation time. When we make RSA take less time in both phases, the efficiency of RSA algorithm will be significantly improved. Then let's go to the next part, the security of RSA algorithm. In this part, we will first introduce two integer factorization algorithms, GNFS and Shor algorithm. The large integer factorization is usually recognized as computational problem. The fastest way is known to GNFS. This algorithm is implemented on a conventional computer. When it comes to complexity, this method is divided into polynomial section, number pair screening, matrix solving, and other process. So its complexity is as follows. The next algorithm is Shor, which is usually implemented on a quantum computer. It allows integer prime factorization in polynomial time, and its complexity is O log n. However, for now, quantum computers are far from being ready for practice use. Over years, researchers have not stopped trying to factorize the large integers. In 1991, the RS100 of 330 bits K is cracked. By 2020, the 829 bits key, RSA 250, is cracked. However, RSA can increase security by continuing increasing the length of key. Typically, they are no less than 248 bits. However, the RSA key length cannot be increased infinitely, because a long key would result in a large space capacity and a longer encryption and decryption times, especially for IoT devices, because they do not have space for high-performance process units and high-capacity storage units. An effective solution to this problem is use ECC. As we can see in the diagram, ECC has a much smaller key size than RSA for the same security level, and do not increase too much bytes when increasing the security level. So in summary, it is still known that the problem of large integer factorization has not been conquered. Although RSA 250 can already be factored, it can be fixed using longer key length. And the vulnerability of RSA 1024 is from an oversight in the software implementation rather than to the RSA algorithm itself. So the RSA algorithm still remain a secure encryption algorithm. And then the last part is conclusion. Today, we introduce the algorithm for improving the RSA efficiency. And in terms of security, RSA is still a secure encryption algorithm and still one of the most popular key algorithm today. So that's all our presentation. Thank you for watching.